let me first read the question. When I'm done reading the question, we'll go back together as a class and we'll write down just the pertinent information. Here's the question. A researcher surveyed 80 adults and found that 22 regularly run for exercise and 18 regularly swim for exercise. Find, the probability that a randomly chosen adult both runs and swims on a regular basis is 1/5. What is the probability that a random chosen adult runs or swims? So let's write down the basic facts. We know we had 80 adults surveyed. Of those 80 adults, and let's actually just this is going to be the facts. We're going to put the facts here, but just to make this simple for you. Okay, you end up getting a questionnaire. You're surveyed with a questionnaire, and you happen to be one of those 80 adults that surveyed, and they said, what do you do for regular exercise? And you have two options. So here are actually 4 things you could do. You could say, hey, I run on a regular basis for exercise. Or you could say, I swim on a regular basis for exercise. Or you could be the super motivated person who goes, I run and swim on a regular basis for exercise. Or you could be Miss Bradley, and both of those boxes are left blank. Okay? 4 options. All right, so we have 80 adults surveyed. Of the 80 adults, 22 state that they run on a regular basis for exercise. 18 state that they swim on a regular basis for exercise. 1/5 of the 80 say they both, that's the key, they both run and swim on a regular basis for exercise. And then please write down the question with me. What is the probability that a randomly chosen adult runs or swims? Please box in the order. Excuse me. Thank you. Frankie asked a good question earlier. Prior to me starting this video, I asked you to write down 3 different groups of information. And he asked, why is there an arrow? Anytime you're asked to find the probability and it gives you an or statement, you will always use one of these 2 options. You will always use one of these 2 options. These have to be memorized. If you're wondering what exactly has to be memorized, what I'm bubbling in has to be memorized. Next, we're going to talk about how do you decipher which one you're going to use. Well, let's look at what we know. We know 22 of the 80 say I run on a regular basis. So write 22 over 80. We're not going to round our decimal answers. Take 22 divided by 80, 22 divided by 80, and write down an answer of 0.275. $18 divided by 80, 0.225. And 1/5 say they both run and swim. So I'm going to take 1/5, and I'm going to take it times 80. 1/5 of 80 is 16. 1/5 of 80 is 16. So 16 of the 80 say they both run and swim, which is a fraction of 1/5. What is 1/5 as a decimal? Many of you already know that. It is an answer of 0.2. The first equation they give you is used when things are disjoint. They have nothing in common. For instance, this represents those who swim, this represents those who run, and then everything that's not in those areas are people who say, I don't swim, I don't run. But for this particular example that we're talking about, they give us a swim section, they give us a run section, and then they even give us a section where we say they overlap. There's a portion where people both say they swim and they run on a regular basis. Since we have an overlapping section, or a section where people say they do both, if you want to write the word both down, that helps us identify we're going to use this equation. So I'm going to write this equation down. But while I do it, I'm going to identify, instead of x's or y's, I'm going to let R represent run and S represent swim. And before you plug in the numbers, which is not a hard task to do, I like to look at this visually. So make yourself a decent sized rectangle. We know there's an overlapping portion, so make yourself, we're doing a Venn diagram, two circles that have an interlapping portion, and I'm going to label this. This is the run portion, and this is the swim portion. So 22 in all. I'm going to use the pencil first. 22 in all say they run, 18 in all say they swim, and 1/5 or 20% of the 80 say they do both. So if you don't remember what the number was that popped up on my calculator, when you take 1/5 of 80, you end up with 16. So in this middle portion, please write 16. These are the 16 who say, I do both. I run and I swim on a regular basis. Now, in total, I can only have 22 runners. 22 that checked run. Doesn't matter if they checked run or run and swim, but 22 total. I already have, here's your circle, I already have 16 in this region. So how many more do I have to add to 16 to end up with 22? The answer is 6. Likewise, only 18 said they swim. So I need 18 total in this entire circle. I already have 16 in this portion, so a 2 goes right here. Now, 80 adults were surveyed. When you take 6 plus 16 plus 2, you end up with 24. Please take 80, subtract 24, and you end up with an answer of, what is it? 56. So 56 is on the outside. So let's just go over this real quick using our little boxes so we understand before we get an answer. How many people only checked run? Can anybody tell me? 6. How many people only checked swim?
2.
How many people checked both?
16.
How many people were like Miss Bradley, unfortunately, right now, and they didn't check anything? 56. Oh, those poor people. Okay, all right, good. So here we go. We want to figure out P of R or S. That or is important. So what is the probability, written as a decimal, what is the probability of randomly choosing one of the 80 who says, I run on a regular basis? 0.275. What is the probability of randomly choosing one of the 80 who says, I swim on a regular basis? 0.225. And I'm so sorry here, guys. Nobody saw that mistake. This is always a subtraction. You subtract the union. Just so you can see here, this is supposed to be subtraction, and I accidentally had an addition sign. Okay, now the union. How many say they do both? The answer is 0.2. Please add and subtract and come up with your answer. Okay, how many were able to get an answer of 0.3? Hands up high. Does anybody want me to show you on a calculator how to come up with 0.3? Okay, here's where you have to be very careful. Circle the word probability and above it write decimal. They asked for the probability, that means we have a decimal answer. This is my final answer done. But if the question would have said, what percentage of a randomly chosen adult runs or swims, our final answer would not be 0.3, but it would be 30%. So read the question real carefully before you write in the answer. Can I give you 1 minute to check with your partner, fill in any gaps and misunderstandings between the two of you, and then we're going to try another one similar. Go ahead. The next problem you're going to do with your partner, let's go over your options. So this time, 50 students are surveyed. 50 students are surveyed. And the survey consists of 2 options. The question is, what do you do in your free time? And you can check, I watch TV or watch movies. Or you could check, I listen to music. Or you could check both. Or you could not check either one. Okay, those are your options. So of the 50 students who are surveyed, of the 50 students, 13 say they choose to watch movies or TV. "22 say they choose to listen to music. 22 say they choose to listen to music. 4 over 25 both watch TV or movies and listen to music. Please find what is the probability, and I'm just going to make up some, use the letters here to represent TV, movies, and music. So what percent that we're given watches movies, TV, or listens to music? Please draw a Venn diagram, fill it out, then use the correct formula to get an answer. Find the probability. Ready? Go. I'd like to hear you talking with your partner through this. Begin. 0.54. Hands up high just so I can see. I have no problem explaining this. Hands raised if you'd like me to explain a portion. Okay, Miguel, can you be specific? Which part? It can be the entire thing if you'd like. Okay, here we go. So 50 students are surveyed in total. 13 of them watch movies, so 13 divided by 50 is 0.26. 22 watch movies, 22 divided by 50 is 0.44. This is going to give us a percentage that does both. So this percentage is 0.16. Good so far? I'm going to fill up this portion. Please take 0.16 for me, Miguel, and take it times 50. 0.16 times 50, do you get an answer of 8? So 8 students do both, but I know only 13 in total watch the movies or TV. So 8 plus 5 is the 13. I know 8 do both, but only a total of 22 listen to music. So 8 plus one number equals 22, it's 14. Good so far? Now because there is an overlapping section, remember like that describes both, since there's an overlapping section, I know I'm going to use this formula between the two OR formulas. Also, I know that there's 50 students in total. When I add these up, I end up with 27. Take 50 minus 27 to get 23. Okay, so what percentage watches movies or TV? 0.26. What percentage listens to music? 0.44. Subtract where they intersect, means what they do for both, which is 0.16. Plug it into the calculator to get an answer. What if they would have said to you guys, what is the percentage of something randomly chosen that watches movies or listens to music in their spare time? 0.54 would be wrong. What would it be? 54%. 54%. Nice job. 1 through 5 on your understanding right now. Again, this is very brief. I understand that. Most of us are 3s or above. Let's go on to the next one. Let's do it in this classroom. Carlos, we're going to make you a sophomore, okay? Is that okay? All right. In this classroom, we only have juniors and sophomores. And let's make up a competition. Let's have a math competition in this classroom. And the winner of the competition, there'll be 3 places, first, second, and third. The winner of the competition will receive a $30 gift certificate from Mr. Camp's office. Second place gets $20. Third place gets $10. Your GPA, your grade in this class, makes no difference. You're going to take a standardized test. Whoever does the best gets how much money? Second place? Third place. Okay, so here's what I want us to do. I want us to identify each of you only, not by your name, but only by your class. You are a sophomore, you're an S, or you're a junior, you're a J. So what possibilities do I have for first place? Who can get first place? A junior? Or who else? A sophomore. Who can get second place? Sophomore, junior. So when I say go with your partner, I want you to identify all the possibilities we have. When there's 3 places, and that we only have 2 types of individuals, sophomores and juniors. 1 minute, begin. Talk to your partner, write them all down.
Because you could have all juniors when you're in the sophomore, senior, and you could have junior, sophomore, junior, or you could have sophomore, junior, sophomore, or you could have and then you could have sophomore, junior. No, she just said that it's only junior, and that's why we changed Carlos, because he's a freshman. What are you doing? Plus, if it was freshman, then you would have 9 probabilities, not 6. You're so cool.
Okay, so let's go over how you do figure this out first of all. So I think it's always good to know how many options you have, so that when you know, okay, I need to get to this many numbers, and you see, oh, I have 5, you know how many more you have to get to. So let's talk about that. Here's first, second, and third. How many options do you have for the first place? 2 options. They're sophomores or juniors. What about the second place? What about the third? 2 times 2 is 4. 4 times 2 is? We need to come up with 8 options. Now listen to the way I explain this, and I'm really hoping that somebody has an easier way to do it. Okay, and a lot of times with things like this that are more sense-based, there will be 1 or 2 students that say, Miss, I think this is an easier way. So please share with me if you have an easier way. So I'm going to start with the J's. It could be junior, junior, junior. It could be junior, junior, sophomore. It could be junior, sophomore, junior. Or it could be junior, sophomore, sophomore. Now I don't want to overthink this, so what I'm going to do is I'm going to take exactly what I have, but now I'm going to flip the juniors and the sophomores. So I'm going to go SSS, SSJ, SJS, SJJ. 1, 2, 3, 4, 5, 6, 7, 8. Thumbs up, thumbs down if you understood how I did it. There could be more than one way of doing this. Okay, so here's the next part. Let's add this to this. Now, of the options we have, what if I said, I only want you to share with me the options that include a minimum of 1 sophomore? How many options would you have? Don't tell me, tell your partner. A minimum of 1 sophomore. So how many options would we have? We would have 7 options. What if I said, please only share with me the options that have a minimum of 2 juniors? How many options would you have? I can only see 4 and I put check marks next to them. Okay? 1 through 5, how well do you understand this problem? 1 through 5. So first you come up with all the possibilities, then really read the question carefully just to determine which ones do you really have to list. Okay, let's go on to another OR problem. Let's do this. When you have 2 events that are occurring, you have 3 possibilities. You're going to put your hands up to do these. So let's go back to, I know we did movies, TVs, and listening to music. What was the first one? Running or swimming?
Yeah.
Okay, so here are your options. You ready? Put both hands up. Your left hand is a running hand. Your right hand is a swimming hand, okay? Right hand swims, left hand runs. Okay, you ready? So you have three options how this is going to work. Those that say I run, never say they swim. Or there could be a small portion like what we just did, where a small portion of them that swim also run, right? Or an option that we haven't talked about is, what if everybody who marked they swim also marked that they ran? Does everybody see that? Yes? So we're assuming that everybody that takes a survey has to bubble at least one thing in. So there's nobody who was like Miss Bradley who said, I don't run or swim on a regular basis, okay? So they're disjoint, they have nothing in common. They have a small portion where they overlap and they both say, I swim and I run. Or everybody that says they swim also say they run. Good to go? Okay, please write down the next problem with me. It is quite lengthy. Give me a second to find it. I'll give you 2 minutes to write it down. Oh man, are you going to be able to do it?
No,
And I'll slowly start moving it upward. Begin writing this down, please.
Do I have to write it down?
Yes, go ahead. You okay, Charlotte?
No.
Keep pushing through. You can do it. Yes, Thursday through Tuesday. Do they know where they'll put you then when we're testing?
We'll just go to the library.
Okay.
Yeah.
Okay, then I'll lock it up.
Hopefully we can still get all of ours done, so we can have it out of the way.
Sure, thank you.
I put a sign on the door, and then I put another one that said Mission Beginnings class, but I went to your kitchen to the library.
Okay, sounds good, thanks.
All right.
Does anybody opposed for me moving up a few lines? One more minute before we go over this. Okay, I'm going to get started. I'll let you finish writing as needed as we go through this problem. Okay, so even if you're not done, can you stop, please? Put both hands up. Remember, I have three options. So if we talk about running and swimming, which I know this is not talking about, but it's the same general idea. If they have to check one, this is their options. They either mark swim or they mark run, but it's swim or run, right? Or they mark, there's a few people that mark both, or everybody marks both because they're completely overlapping. Does everybody get that? This particular problem is talking about being a senior, and it's talking about being a marching band. The key part I underlined, it says that the probability of being a senior, so P of being a senior, is the same. That means is equal to the probability of being in marching band. They're exactly the same. So here's what our different options are before we even look at this problem. We're talking about the lowest possibility and the highest possibility. So lowest and highest. We're not talking about anything in between that's like this. We're talking about lowest and highest. Does everybody see that? The two extremes, but nothing that's in between, okay? Lowest and highest. So our one option looks like this. It's disjoint. It's where your hands are separated. What is this probability? So this would be the probability of being a senior or being in marching band. And since they're disjoint, remember we have to memorize it. It's P of S plus P of MB. We know the answer because it says the answer of them using the OR statement is 0.76. Now how do I come up with these? Well, the only thing you know is that they're exactly the same. It stays up above. They're exactly the same. So let's just use a random variable like x. If I say the probability of randomly choosing a student that's a senior is x, Well, if this is x, that means this has to also be x because it says they are the same. Let's solve for x. 2x equals 0.76. Divide by 2, divide by 2. X equals 0.38. So whether part A said, what's the lowest possible probability that a student was chosen at random is a senior, that's the answer. Or if it said, what is the lowest possible probability that a student chosen at random is in marching band, that is also the same answer. Why is it the same for both? Because they're equal. Okay? Turn to your partner to make sure they understand the first before we do a second. Okay, now we're going to go with the highest possibility. So again, these are our options. Here, this is your middle option. This is your highest option. So you only have one circle. Draw your Venn diagram, but the circle representing senior is going to go right over the top of the circle representing marching band. So this is the circle for seniors, and it's also the circle for marching band. And then when you have to draw a circle where they overlap, 100% of them overlap. It's also the circle. It's also the circle for overlapping. So this is S, not an ugly N, but an upside down U, which represent intersection of MB. So I'm going to write down the formula here. Give you a chance to write that down. Okay, so it tells us this OR statement, my final answer is 0.76. And we know that each one of these is exactly the same. Notice this. Do you notice how this circle represents S, yes or no? And this circle represents MB, right? And this circle represents where they intersect because they're all exactly the same. So if these are all exactly the same, let's write down X plus X minus X. 1X plus 1X is 2X. But 2X minus X is just 1X. So what is X actually equal to? 0.76. I can go above this and write 0.76, 0.76, 0.76. That means this circle is 0.76. Okay, so what is the highest possible probability that a student chosen at random is on the marching band? 0.76. What if we interchange marching band to being the highest possible probability of being a senior? 0.76. What if we change it to say, what is the highest possible probability of being a senior and on the marching band? What's the answer? 0.76. It said probability. My answer is 0.76. What if they would have said percentage? 76%. Great job. You're going to do one like this, and let's do one, and let's talk about daycare with my son. Okay, you ready? So at daycare, we are told that the percentage of male children is equal to the percentage of toddlers. The percentage of male children is equal to the percentage of toddlers. We're also told the probability that a child is a male or a toddler is 0.20. Okay, So question A, don't feel like you have to write down these questions, is what is the highest possible probability that a randomly selected child is a male? With your partner, find that answer, and then I'll write down the second question next. So working on part A with your partner.
And you didn't write anything down. So the usual percent is going to be for my answer. It's going to be 4.6. 120 for everything because everything's equal to everything.
It stands for probability. And I'll specifically ask for percentage if it's needed. Mhm. So do this again, guys. Here are your options. This is always low because there's nothing connected. Here's where they have something connected. This is the highest, so it's 100% overlap. So we're looking at the highest, 100% overlap. So let's draw the picture. This represents male child. This also represents what else? Toddler. And it represents male and toddler where they intersect. So here's the formula. The formula goes like this. Probability of being a male or a toddler is probability of male plus probability of toddler minus the intersection of male and toddler. We know this answer is 0.2, 0.2. We don't know the probability of M or the probability of T or the probability where they intersect. But we do know they're all the same because it's 100% intersection. So X plus X minus X. So what does that make X?
Or 0.20.
It makes it 0.20. So what is the highest possible probability of randomly selecting a child that's a male? The answer is, but what if they would have said, what's the highest possible probability of randomly selecting a toddler? 0.20, good. Now down here, same thing as what we did before. This is where we have 100% disjoint. So it's going to be probability of male or toddler is equal to the probability of a male plus the probability of a toddler. We know these are the same. How do we know that? That was given in the description of this problem. So when you add up the two x's and then divide by 2, the answer is 0.10. These would be your two answers. And unless they said what's the probability, unless they said what's the percentage, you leave them just like that. You don't round. If they said percentage, it'd be 20% and 10%. Thumbs up, thumbs down. I know that was a heck of a lot of information.